Okay, we were just noticing that when we add 2 to a function, it shifts it up 2. When we add 2 to the inside of the function, inside the parentheses, under the square root, inside the absolute value signs, again, in the parentheses cubed, it moves it to the left 2. We're adding 2, but it moves it to the left 2. Let's see what happens if we multiply by 2. Okay, 2 times x. Okay, y equals 2x. Well, we're going to have 0, 0. If I put 1 in for 2, 2 times 1 is 2. If I put 2 in for 2, or for x, 2 times 2 is 4. It's kind of a steeper line than y equals x was. 2x squared, 0 still gives me 0. 1 squared is 1, but then I multiply it by 2. 2 squared is 4, but then I multiply it by 2, so I'm up to 8. So, again, we're getting bigger faster, okay, just like with the line. Negative 1 squared, of course, is 1 times 2 is 2. Negative 2 squared is 4 times 2 is 8. So I don't know if you can see, but this parabola is thinner, okay? It's stretched towards the y-axis. It's like I took the parabola and just stretched it. 2 times the square root of x. Again, when I'm 0, I'm 0. Square root of 1 is 1, but I'm multiplied by 2. Square root of 4 is 2, multiplied by 2. I get 8. Okay, so I was 4, I was at 8. Okay, so, I'm sorry, 4. Square root of 4 is 2. 2 times 2 is 4. I'm like, wait, that's not going to look right. Okay, so remember what the square root graph looked like. It's getting taller faster. It's still not as steep as this line or the parabola, but you have the idea. 2 squared to x. We have 0, 0, 1, 2. Negative 1 squared, or absolute value negative 1 is 1, times 2 is 2. 2, 4. Negative 2, also 4. We get the v, but it's a little bit thinner of a v. Again, stretched towards the y-axis. Cubed root of, or the cube, 2 cubed, 0, 0. 1 gives me 2. 2 cubes, 8 times 2, 16. I can't even, I'm off the charts with that. It's the same shape, but really skinny, really towards that y-axis. Okay, so multiplying, notice it didn't shift it anywhere. I'm still starting right here at 0, 0. I didn't shift it up or to the left or to the right or down. I just stretched it, and it was just skinnier because it's getting bigger faster towards the y-axis. Okay, if I do similarly with a half, it's going to be a similar situation. I'm not going to move it any direction, but when I put 2 in, half of 2 is only 1. When I put negative 2 in, half of negative 2 is negative 1. It's not as steep, right? It has the slope of a half. 1/2 x squared, I'm still here at 0, 0. When I put 1 in, half of 1's only a half. Negative 1's a half. 2 squared is 4, but then I'm taking half of that. 2, I'm only up to 2. It's a wider parabola. It's still a parabola. It's just wider, just like the line is not as steep. The same with the square root. 0, I'm still at 0. Let's put 4 in. Square root of 4 is 2, but then half of 2 is only 1. So I'm just, I'm still going in the same direction as the square root, but not as steep. 1/2 absolute value of x, we have the same type thing. Okay, where it's just making it wider. We'll use the word compressing it instead of stretching. If I put a negative in front of my graph, okay, 0 is still 0. When I put 1 in, instead of being 1, I'm at -1. When I put -1 in, instead of, I'm the opposite of that, which is 1. So we have a slope that's going down instead of up. -x squared, similar situation here where we're trying to pull this screen down a little bit so we can see better. -x squared, 0, 0. 1 squared is 1, but then I take the opposite of that, which is -1. -1 squared is 1. Opposite of that is -1. -2 squared, or 2 squared is 4, but the opposite of that is -4. So I'm going to be 1, 2, 3 down here. -2 squared is 4, but the opposite of that is -4. So it takes our parabola and flips it upside down. The square root function, 0, 0. Square root of 1 is 1. The opposite of that's -1. Square root of 4 is 2. The opposite of that's -2. It's down here. So basically what happens is I'm flipping my graph over the x-axis. Absolute value of x, absolute value of 1 is 1, but the opposite of that is -1. Same with 2, -2. We get a v that's upside down. Okay? It's hard to see this with -x cubed, but we remember what x cubed looks like. It's going to be going this way. It's like I just took the usual cube root and flipped it upside down around. We flip it around the x-axis. Okay, so let's look at what happens with something like this, a negative inside the square root. I know that seems weird, but what we're going to do, we have to be careful what kind of x's we put in, because I can only take the square root of positives. 0 is fine, but I'm going to put in -1, because then the opposite of -1 is 1. I can take the square root of that. I'm going to put -4. The opposite of -4 is 4. I can take the square root of that. So we end up getting a situation where we're flipped over the y-axis. Okay, our usual square root function is like this. We just flipped it over the y-axis when we put the negative inside the square root. Okay, so here's a summary of what we're seeing. If we have y equals some number a times some function, I don't care if it's square root or if it's, it just doesn't matter if it's square root, square, cube root, cube, absolute value, whatever the function is, if you do that to b and then in parentheses x minus h plus k, what happens is a, this number in front of the function. In other words, that was back when we were doing this, the 2 or the half. Okay, a number in front of the function, that's what a is, stretches it when the absolute value of a is bigger than 1, like 2, 3, 4. Less than 1, like a half, it compresses it. If a is absolutely less than 0, it flips the graph upside down, okay, like we saw. Flips it over the, I like to say over the x-axis. They sit upside down. This is supposed to say, oopsies. This is supposed to say H, and this is K. Okay, H. I use HK, and the book doesn't. Okay, H is a horizontal shift. If H is less than 0, it shifts it to the right. If it's bigger than 0, it shifts it to the left. So when our H, see, because the minus is in here, just like with the circle, when it was x minus 2, the center was at like 2, whatever. If it was x plus 2, then the center was at -2. Okay, the minus is part of the equation here. So if I have an H that's less than 0, like -2, you're probably going to see that written as x plus 2. That would mean H is -2, and it's going to shift it to the right. We saw, what I showed you was just a regular, just 8x minus 2, and that shifted it to the left. Okay. The K value is the vertical shift. That moves it straight up. That was the very first thing I showed you right here. That's what I mean by K, is added at the end of the function. And that shifted it up. This was added on the inside. This was the H. And here H is -2, so it shifted it to the left. Okay, so anyway, K is the vertical shift. If K is bigger than 0, it shifts it up, like we saw. If K would be less than 0, it shifts it down. And we don't see this too often with the number here in front of the x minus h, but that is a horizontal compression or a horizontal stretch. And if it's less than 0, it flips the graph across the y-axis, left and right. Okay, that was what I just showed you here. A negative right inside the parentheses, not on the outside of the absolute value, but on the inside. And it flipped it, like they're saying, flipped it left and right instead of upside down. Okay? Anyway, a little summary there of all the different transformations. Okay? Now, the other part of this that's new is looking at a graph and deciding, first of all, is it a function? Yes, we're only going to be looking at functions, to tell you the truth from this point on. Domain and range, being able to tell that the domain and range here is all reals because the arrows are going in either direction. Doesn't seem to be anything, you know, stopping us from going up and down and right and left. Symmetry, we're going to be talking about symmetry across the y-axis, across the x-axis. Well, it can't be symmetric across the x-axis. It wouldn't be a function. Symmetry across the y-axis or across the origin. And this one doesn't have that kind of symmetry. If I would fold this graph on the y-axis, it's not the exact same on the right and left. And if I would look across y equals x, which would help me across the origin, it's not the same across y equals x. Okay. Basically, if it's y-axis symmetry, then we call it even. That's if it's symmetrical across y, which this is not. We call it odd if it's symmetric across the origin. Okay, and what happens there is for every xy that you have, negative x, negative y will also be there. So for example, if 2 3's on my graph, so will -2, -3 be on my graph. That's how you know it's symmetric across the origin. I always just check some points and see if it's always going to work that way. Symmetric across y is easier because I can just look at the graph and see if I fold it across the y-axis, is it exactly the same on either side? Okay, this has none of that symmetry. Where's it increasing and where's it decreasing? I can see that my graph is going down from here to here and also from here to here. Okay, so I'm looking for this spot on the x-axis. That's where I stop decreasing. Okay, so I'm decreasing from -infinity to -1.5. Okay, because this is -1 right here. It's going by fourths. I don't know if you can see that. I mean by halves. 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So anyway, as soon as my x goes from -infinity to -1.5, I am decreasing. I'm also decreasing right here. Let's see, where's that? 1/2. So in union with 1/2 to infinity. That's from decreasing. Okay, we'll stop for a sec.